In solving quadratic equations, we realized that the old way of doing it didn't work. We couldn't put x squared and x together, and so we came up with factoring as a way to do this. But some equations, such as this one, don't factor. So we're stuck with how to do that. Well, we're going to take a step back, and we're going to teach you another way of doing it. It's called completing the square. Now, completing the square is going to allow us to take care of things that don't factor. So we start with a nice easy one that we've done before. X squared equals 9. Now, if you recall, we could do this one with factoring. And we got it equal to 0, so x squared minus 9 equals 0. Then we did x plus 3, x minus 3. That equaled 0, and then we have x equals minus 3 and x equals positive 3, or we could write it like this, a positive or a negative 3. So this lists off both answers at once. Now if we take that, and we know what the answers are, we can look over here and say, now wait a second. If I think about going way, way back to the beginning of algebra and just peeling off numbers to get x by itself, I really only have to get rid of that number right there, that 2. It's a power squared. So if we do the opposite of that and square root both sides, we get x equals 3. Now as you look at these two, this square rooting gave us the number 3. Factoring gave us 3 and negative 3. If we check out negative 3 over here, negative 3 squared, it does indeed give us 9. And so we realize that square rooting just straight like itself doesn't give us all of the answers. So the shortcut is, whenever you square root, you need to put a plus or a minus so that you always get all of the answers. The technical version, for those of you that want to know, is I want you to look at the number x. X could be positive or negative. When you square it, it becomes positive. Whether it was a negative or a positive, it became a positive, and we square rooted it and it became a positive. So there's another operation that takes any number, positive or negative, and turns it positive, and that is absolute value. So technically there are absolute value signs here, and that is what, when you break it apart, absolute value of x equals 3, you get an x equals a positive 3 and a negative 3. That's the technical reason for that plus or minus, but for most of you, just recall, if you square root, you've got to do plus or minus because a negative squared and a positive squared both act the same way. So let's try another one. You have x squared equals 16. What we're going to be able to do is just square root. Remember that we have to have a plus or a minus, and we get as an answer x equals plus or minus 4. Both of them work. Now the reason this is so valuable is this equation could have been factored, subtract 16 and factor it just like that. But if we take a look at this one, x squared equals 7. If we subtract that over, x squared minus 7 doesn't factor. It doesn't work. However, we can still do this same thing we've been doing. Square root here, square root there. Be sure you do a plus or a minus. And now we have as our answers x equals plus or minus the square root of 7. It's an irrational answer. Factoring will only ever give us fractions, rational answers. So when the answer really is irrational, factoring, this guy right here, it's not sufficient for our needs. So this right here will allow us to solve more equations. Let's do another one down here. I'll show you another way that we can get some cool stuff out of this. If we have x squared plus 25 equals 0. This is one of those sum of squares that doesn't factor at all. And look at this. We can take x squared, subtract 25 from both sides, like that. Now if we square root and square root, don't you forget that plus or minus. That's very important. Then we have x equals, well, the square root of 25 is 5, and the square root of negative 1 is I. So we simplify these square roots if we can, and we get a positive 5i and a negative 5i to solve this equation. This actually gets bigger and bigger. I'll show you what I mean. if we have something where I have x plus 4 altogether squared equaling, let's say 11, we can do the same thing here. If we've got a perfect square on this side, then we undo that perfect square with a square root. Don't forget your plus or minus. So we now have x plus 4 equals plus or minus the square root of 11. If we subtract 4 and subtract 4, we have x equals positive square root of 11 minus 4 and negative square root of 11 minus 4. Or we can also write it like this: negative 4 plus the square root of 11, negative 4 minus the square root of 11. Kind of handy, that. Let's do one more up here. Maybe a couple more, but we'll see. X minus 3 squared equals negative 16. We have a perfect square again, so we square root. Don't forget that plus or minus. And then we have x minus 3 equals plus or minus. Square root of 16 is 4. Square root of negative is I. And so now we add 3 to both sides. So we get as the answers x equals 3 plus or minus 4i. And when we do this, 3 plus or minus 4i, notice what happens. Every time we take this square root with the plus or minus, and then this number comes over, we always get conjugates. How cool is that? They come in conjugate pairs because the plus or minus always happens in front of the square root. Now, one last one before we go to this guy right here. This is when it's nice and neat in a square. So recognizing when something is in a square is kind of important. So if we had something like x squared minus 14x plus 49 equals 11. We did 11 once before. Let's do something else. Negative 3. Now this guy can be written as x minus 7 altogether squared. This is half of that, and that's perfectly squared, equals a negative 3. Now that it's in this format, it's kind of nice. We can square root, don't forget the plus or minus, and then carry on with x minus 7 equals plus or minus square root of 3, and add 7 to both sides. We get x equals 7 plus the square root of 3, 7 minus the square root of 3 as our two answers. So now we jump to the final question here. This is not a perfect square. We need a different number here in order for it to be a perfect square. So here's how we do it. Take that guy, get him out of the way. So we now have x squared plus 6x, and then we leave a space for the number that we want to put there. So we subtracted 2 from both sides. So now we have a number that we need right there. So we take half of this is 3 squared is 9. We add 9 right there. Because we're in an equation, you need to add 9 to both sides, and we have now, ta-da, created a perfect square. This can be written as x plus 3 altogether squared, and over here it equals 7. So we, that's nice, square root, plus or minus, x plus 3 equals plus or minus square root of 7, and x equals, so subtract 3, negative 3 plus or minus the square root of 7. And there we have it. This was an equation that didn't solve. We picked this 9 just out of the air and threw it in there to complete this square, hence the name complete the square, completing the square. You're putting that number in there to complete that, to make it a perfect square, so that this whole concept of square rooting is kind of nice. Let's do one more, kind of tougher one. Let's do one that doesn't come out really nice. So x squared plus 7x plus 1 equals 0. So the first step is to get that guy over there. So we now have x squared plus 7x, and that equals a negative 1. Ooh, now this is going to be tough because the number we stick in here has to be half of 7 So 7/2 squared is 49/4. We got to add that to both sides. So that makes the one side, oh, that's good, that makes an x plus 7/2 altogether squared. And on the other side, we get 49/4 minus 4/4, so that's 45/4. Now we're going to square root, don't forget your plus or minus, and we get x plus 7/2 equals plus or minus the square root of 45 over square root of 4 is 2. So x equals negative 7/2 plus or minus. Now the square root of 45, this is 9 times 5 in there. Square root of 9 is 3. So simplify it down as much as you can. And you can write it all together like negative 7 plus or minus 3 square roots of 5 all over 2. If you want to add those two fractions together, that's perfectly fine.